As Susannah mentioned, we're going to be focusing on public rights-of-way and discussing a little bit about the balance between environmental stewardship and critical infrastructure, electric utility lines, and also touch a little bit on some other linear corridors and opportunities for biodiversity promotion there. My objectives with the presentation are that when I'm done, you'd be able to understand, first of all, that there's different classes of electric lines and they're not all managed the same. And then we'd identify integrated vegetation management control options and how we can use them to contribute to biodiversity. And finally, describe some management zones and their application to integrated vegetation management. First, there are 4 classes of lines, and 3 of them really don't have a lot of opportunity for us to be able to focus on in terms of our topic today. In the lower right, you see cable TV, and they're the lowest on the line. They don't generally designed to be carrying electricity. It's telecom lines, not just cable TV, but fiber optic lines, telephone lines, and so forth. Generally, what we find is that the higher up on a pole and the more robust the structure, the more important the lines are, the more electricity they carry, and the greater the consequences for having an outage. On the left, we see 2 classes of distribution lines. On the top, secondary lines, I've noted a triplex line. That's a service drop, insulated lines of 120 to 240 volts. On the lower left, the secondary lines are older construction, often called open wire secondaries, and again, they're 120 to 240 volts that serve a customer or 2. On top of the poles, the distribution poles that are in our neighborhood, we see a crossarm in this case. Sometimes they're single poles. But we have distribution lines that can be energized to thousands of volts. Utilities tend to keep trees away from distribution lines, particularly primary lines, by pruning, sometimes by removal. But our focus today are going to be on the transmission corridors. If we look on the upper right, we see transmission lines on much more robust structures, an H structure on the right, which is, in this case, carrying 230,000 volts. And on the left side, an even larger structure, steel lattice, carrying 500,000 volts. An enormous amount of electricity. An outage on one of those lines can be catastrophic in nature, and we'll discuss that in a second, I think. Utilities can use these corridors to convert the area from a tall-growing plant community to a lower-growing plant community. And our objective lately is, rather than look at these areas as sacrifice areas because we can't grow trees there, to leverage them for biodiversity, with advantages to the utility and advantages to our electric customers in terms of providing safe, reliable electricity. So utilities clear trees away from power lines for reasons of safety, service reliability, governmental regulations, access, economics, and environmental stewardship. We talked about service reliability and catastrophic outages, including those of you in the eastern United States will remember the outage from August 14, 2003, which left 50 million people without power, some for as long as a month, and resulted in 8 deaths. That was initiated by a transmission line contacting a tree in Ohio. Utilities report that between 20 and 30% of all their lost customer minutes, all their outages, are due to vegetation. So utilities need to keep trees away from power lines for service reliability and also for safety. Close to mind is the fire that incinerated Paradise, California a few years ago that was initiated by a tree power line contact. And of course, every year people contact power lines that they access through trees, and utilities have a responsibility to keep that from happening. So they clear trees away from power lines, and increasingly our design and what we're encouraging is cover type conversion. If you see the picture there, what we're trying to promote are plant communities that are consistent with the use of the line, made up of species that will never grow into the power line. But yet we can leverage that for biodiversity by creating meadow or prairie habitats that are important for bees and promoting bees, ground nesting birds, other songbirds, lizards and reptiles, and other creatures. And we'll talk about that here. The International Society of Arboriculture is working on a third edition of the best practices for integrated vegetation management that I'm the author of, but we have a committee of experts helping with it. We're closing up work on it actually tomorrow, and there are several different types of control methods. Most commonly used are physical methods, like the machine you see on top, an excavator with a stump cutter, a masticating head, and chemical control methods. Now, there's purpose for these, but we increasingly are trying to say, as I just referred, to promoting a biological method called cover type conversion. Now, that might begin with a physical method or a chemical method, but our idea is to increasingly promote a plant community that's tree resistant, a plant community that's consistent with the use of the right-of-way, delivering electricity, and then also leveraging that site as an area opportunity for biodiversity. Chemical controls often begin with this, and physical control, and it might require a relatively large amount of chemical control to begin with. But the idea is that as the plant community that is consistent with the use of the site develops, a low-growing plant community, they can become tree resistant and outcompete tall-growing species for the line and require less and less intervention on the part of the utility while providing habitat. Here's an example of how it might work. On top on the right, you see a power line that had been reclaimed a couple years before. It had been full of tall-growing species that were threatening the 230,000-volt line in southern Oregon. 2 years later, a lot of those deciduous species began to grow up, and it required quite a bit of herbicide application. But the next time we went through, there was much less because the compatible species were growing in, beginning to dominate the right-of-way. A couple years later, even less and less and less, until the picture on the bottom I took 20 years later. We see a right-of-way dominated by manzanita, a low-growing shrub that's not going to grow up in the power line and provides pollinator habitat. And we also have grasses and other low-growing species. And by that time, all we had to do to maintain the right-of-way is maybe have a single individual with a backpack spraying an isolated sapling of a tall-growing tree here and there, and it turns out to be very inexpensive for the utility. So this is a win-win. The utility saves money, we enhance the environment, and provide early successional habitat that might be lacking in many areas. We can also do this with a cultural control. We might remove the trees and then hydroseed an area with a meadow or a prairie plant community to conduct cover type conversion. The idea of cover type conversion was developed by wildlife biologists in the late 1940s and early 1950s with the development of phenoxy herbicides, synthetic auxins that kill broadleaf plants and not grasses. Most notably for the utility sector, William Bramble and William Burns started using cover type conversion in the early 1950s in Pennsylvania in a wildlife reserve called Game Lands 33. There was a transmission, and still is, a transmission corridor that went through the area, and hunters were concerned that the application of herbicides were harming the animals. And being wildlife biologists, they said, okay, let's test it. And so they began a research project that is still ongoing now, well over 65 years later, 68 years later. And what they found is where they selectively use herbicides at a small level and use cover type conversion to dominate a right-of-way, they not only protected the right-of-way, but they found a greater diversity of sensitive environmental indicator species, pollinators, ground nesting birds, other songbirds, reptiles, amphibians, and so forth. The picture on the bottom you see was taken 55 years after the picture on the top in the identical place. So this has become a stable plant community with minimal intervention. And now Dr. Carol Mahan at Penn State University is still conducting research there today, particularly emphasizing pollinators, and she has identified bee species, if I remember right, I'm going to get into trouble, but rusty patch bumblebee, which hadn't been collected in the area for decades and thought to have been extinct in the region, but found rusty patch bumblebee utilizing and foraging on this right-of-way. So some very exciting work that's good for the utility, good for our infrastructure, and good for biodiversity. Bramble and Burns said that they could create even more habitat by managing in zones. So if the line is right off the ground, they had a wire zone right underneath the wire where they manage for a meadow or a prairie plant community. Off to the side, you might allow shrubs and low-growing trees to develop. So they have a border zone that forms an ecotone into the off right-of-way area. And then on the bottom, that can be modified if the line's high off the ground. If it crosses for canyon bottoms that are over 100 feet off the ground, for example, we don't need to remove trees. It's a waste of money. We can retain them. If it's a little bit lower to the ground, maybe 50 to 100 feet, we can have a border zone community of shrubs and small trees throughout the right-of-way. And where the line's low to the ground, we can have a wire zone, border zone community. And this can be applied to pipelines. Right over the pipe, you have a pipe zone with a border zone on the side. Oh, back up. It can be done on railroad rights-of-way. Where the tracks are in the ballast zone, we have to have an area free of plants. But off to the side, we can have an analog to our wire zone or pipe zone, and then a border zone along the side, and railroads are managing this way increasingly as a best practice. And the same can be said for roadways. The pavement and the shoulder needs to be kept free of vegetation, but then we can have an analog to our wire zone, border zone, or wire zone or pipe zone adjacent to the pavement, and then a border zone alongside that we can maintain for pollinators and biodiversity. And we had Department of Transportation people helping advise us in the best management practice that I'm running that's going to be available through the International Society of Arboriculture in September. The utility industry is trying to award utilities for environmental stewardship, and the Right-of-Way Habitat Council has an accreditation program that recognizes utilities that are promoting cover type conversion and pollinator habitat. And I'm happy to provide more information about this. So in conclusion, there's 4 classes of line, but integrated vegetation management and cover type conversion is most often applied to transmission lines. Integrated vegetation management include biological, chemical, cultural, prescribed fire, and physical, but biological methods should be preferred for cover type conversion for ecological, economic, and for practical reasons. And finally, linear rights-of-way are often managed in zones. That concludes my prepared remarks. I guess we have a few minutes here to try to field some questions.